I've been doing mine water work since the late 1980s. I started working at the U.S. Bureau of Mines, which was part of the Department of the Interior, a federal research organization that focused on mining problems. And started my own business, Head Environmental, because I wanted to build these systems that we were instructing people how to build. We still often commonly refer to all mine drainage that has any color to it or any toxic effects as acid mine drainage. In fact, there's a lot of mine drainage especially that comes out of flooded underground coal mines that's alkaline in character, but is contaminated with high elevations of iron. And in western Pennsylvania, a lot of our orange streams are polluted with alkaline mine drainage from flooded underground deep mines. With alkaline mine water, you're not far from having a viable ecological system if you can just get the iron out of the water. The Lowber system is special in that it treats a very large deep mine discharge. It's an alkaline flow. It flows on average about 1,800 gallons per minute. It contains 70 milligrams per liter iron. That's about a ton of iron solids coming out of the mine every day and flowing at the time before the system was built into Swickley Creek, which flowed into the Youghiogheny River. It stained the creek orange and it stained the river orange. Because the water is alkaline, the treatment is actually very straightforward. Aerate the water and cause the iron to oxidize to form an iron oxide solid. We need to then remove that solid. And it's the same thing that happens in Swickley Creek and that was happening in the Youghiogheny River. Our challenge was to cause that to happen on the site that the Swickley Creek Watershed Association had, with some foresight, purchased from the old coal mining company that was on this site. The Lowber system is one of the largest passive treatment systems that's been constructed in Pennsylvania, which by default is in the world. We did some calculations and we determined how much land we needed to remove all this iron on that site. A lot of times we do these calculations and we need 3 acres and we have a half an acre. In this case, we needed about 18 acres and we had 18 acres. And so we realized we were able to make it work here. When the solids concentrations get down to low levels of 10 milligrams per liter, the ponds aren't very effective at removing the residual iron. It's present as a very finely suspended solid. Well, what's well known in the water treatment world is that wetlands are great for removing those kinds of conditions.
Once we decide that something needs to be removed from the water, the question becomes, where does it go?
We have to think about the fact that we're going to precipitate a lot of iron sludge. And if we ignore that sludge, that will fill up our treatment system and it will fail because of that.
These passive systems, they are low maintenance, but not no maintenance. We've been very blessed in that our systems have lasted longer than the predicted life.
There have been many passive treatment systems, unfortunately, that have failed because of the accumulation of sludges in them that haven't been properly managed.
Treatment systems were built. They were called passive treatment systems, and people thought that you could build it and walk away and not worry about it anymore. And that could not be farther from the truth.
We actually built 6 ponds, but those ponds are filling up with iron sludge, 8 to 10 inches of sludge, and eventually that'll be a problem. We designed the system to allow pumps to be put into them to pump the sludge out. We actually cleaned out the first 3 ponds, all the sludge in the first 3 ponds. We did that with financial support from the Western Pennsylvania Coalition for Abandoned Mine Reclamation, a Growing Greener grant they had that supported iron sludge recovery and management at these sites, and through a grant from the Foundation for Pennsylvania Watersheds. And also my company then, we also put in about half of the funds. We pumped the sludge and collected it into these large fabric bags called geotubes, which is a permeable, woven, very sturdy fabric. The idea is the solids stay inside while water leaches out. We pumped about 2,500 tons of sludge, wet sludge, into these bags. We will then take it to our processing facility where we'll dry it further and screen it and package it so that hopefully we can sell it as an iron oxide pigment product. The sale of the iron oxide pigment is something that we've been doing since 2000. and we actually gave it a name. We call it an environoxide. It's an environmental iron oxide. Hoover Color Corporation, they're in Virginia. They take what we give them and they dry it, screen it, particle size it. And this is what would go into wood stain, would go into paint, would go into plastics to give it this burnt sienna color.
A very unique partnership that has resulted in good business, as well as restoration of a watershed.
If we can take iron oxide from mine drainage and turn it into a usable product, that means that somebody like myself can go out and can manage the sludge at these treatment systems, hopefully for free.